Hello, and welcome to the Hacienda Healthcare iStat Competency in Service. Today we will discuss the iStat device and quality assurance procedures, which includes the daily simulation, the monthly controls, the calibration verification, and the quarterly proficiencies. But first, let's discuss the iStat device kit, which contains the handheld analyzer, the printer, the simulation cartridge, and the iStat manual. The iStat device kit and all the accessories as well as the documentation materials are located in the iStat lab. Next item of discussion is quality assurance. We are required by law to perform quality assurance procedures to ensure the accuracy of the testing device. The daily simulation, which is a lead tech duty, is performed every 8 hours, and the results must be documented in the action log. Failed results require immediate notification of the supervisor. Daily simulation times are set for 6 a.m., 2 p.m., and 10:30 p.m.
Hello, today I'm going to be showing you how to run the iStat quality control as part of the Lead Tech daily procedures. The first step we're going to go through is to turn the handheld on, and you're going to press number 2 for the simulator. Insert. You're going to enter your operator ID, which can be found in the iStat room here. And that will be entered twice. Since we're doing the simulator, there is no patient ID, so enter twice. You will then scan or enter the simulator ID. You can either scan the box top, or the simulator ID number can be found on the bottom of the simulator. Once you have your results, you are going to print by pressing the print button. You will then hit number 1 to go back to the menu and remove the simulator and power off the handheld.
In addition to the daily simulation, we are required by law to run monthly controls. The monthly controls are done every 30 days. It is a lead tech duty, but we are required to rotate the staff, and the results are documented on a monthly log. The value compliance criteria is found on the ABBOTT Laboratory Value Assignment Sheet, and out-of-range results require corrective action, so notify your supervisor if any analyte is out of range. Controls must also be performed on every new box of cartridges before it is used on the patients. Items needed to run a monthly control includes controls level 1, 3, and 5 at room temperature for at least 4 hours. Each control must be vigorously shaken for 10 to 20 seconds before use. The iStat G3 Plus cartridge at room temperature for at least 15 minutes out of the box. 16 to 20 gauge needles and a 1 to 3 milliliter syringe. Make sure that you expel 1 to 2 drops before inserting the sample into the cartridge. Now that we know that the device is functioning properly, it is ready to use on the patient. Remember, before you perform a blood gas, a physician's order is required. It is also important that you assess for the appropriate puncture site and that you perform no more than 3 sticks per attempt on a shift. When you are done, the copy of the results must be placed with the order. The physician must be notified of the results, and a copy of the results are also logged in the blood gas log.
We are going to demonstrate the procedure for an ABG draw. First of all, you need the doctor's orders, the patient ID number, which is found in the patient's chart, your code number, which is located on the cupboard door in the iStat room. You need several ABG kits. I would suggest taking 3, as 3 tries is the most you can do at one time. Let's open an ABG kit and see what it contains. Have your gauze, alcohol swabs, your syringe, which has heparin in it, Band-Aids, and a bag. Okay. You also need several cartridges for the calibrating iStat machine. They're refrigerated, so you need to keep them out for several minutes to warm them up. If possible, if you have a talking patient, inform them that you will be doing a blood gas on them. Enter the patient's room. Find the best area on the patient's arm where the pulse is the strongest. This may take a few minutes. Once you have found the best pulse, you need to swab that area with an alcohol pad. Okay, then you will take your syringe out. Insert the syringe on the end of the cartridge, and then move the cartridge up several times, 3 or 4 times, to release the heparin. Good job. Then you can take the cap off of the syringe, and at a 45-degree angle, approximately, bevel up, you will insert the needle right in front of the area that you found the pulse in. You will insert the needle and hopefully you will see a flash. That means you have hit the artery, and the syringe will start to fill. Once you've gotten enough blood, which probably takes maybe a half a cc to a cc, but get as much as you can, because you might need a couple of tries with the cartridge. Remove the needle. Apply pressure to the puncture site. And carefully insert the blood after you've put the Band-Aid on the patient. Carefully insert the blood into the iStat cartridge, which is very small. And for your information, too much blood in the cartridge will make the cartridge burst in the calibrator machine. Too little blood in the cartridge and it won't read. So carefully, it doesn't take much. There's a little circle and there's like a thermostat reading. So put a tiny amount of blood in there. Remember, blood is pretty thick. It goes to there, cap it off. Put it in turn the iStat machine on. It says first, last result to iStat cartridge. You'll press iStat cartridge. It says insert cartridge. Operator ID. Enter again. Repeat putting your ID until it tells you to do something else. It's identifying the cartridge. This might take a minute or two. Okay, it's calibrating. Once it's done calibrating and you get your information, you need to take the cartridge out, dispose of it all into a red box, and then you need to make copies. You need to make a copy, and one of them goes into the iStat log with all the information on the cartridge, and one with the patient lab results and the patient chart. And that is how you do an ABG.
The first step in interpreting blood gases is assessing normal values. Normal ABG values are as follows: pH 7.35 to 7.45, CO2 35 to 45, and HCO3 22 to 26. Once you receive your blood gas results, ask these 4 basic questions. Is the ABG normal? Is the pH acidotic or alkalotic? Is the cause respiratory or metabolic? Or is the cause compensated or uncompensated? Is the ABG normal? If all the results are within the normal range, then you have a normal ABG and you can stop here. If any of the values is out of the normal range, then you must move to the next question. Is the pH acidotic or alkalotic? To determine this, you look at only the pH. If the pH is greater than 7.40, the patient is alkalotic. If the pH is below 7.40, the patient is acidotic. Is the cause respiratory or metabolic? To determine this, you look at the pH and compare it with the HCO3 and the CO2. If the pH is acidotic, you look for whichever value, HCO3 or CO2, that is also acidotic. If the pH is alkalotic, you look for whatever value, HCO3 or CO2, that is also alkalotic. In this sense, you match the pH with the HCO3 and the CO2. If the pH matches the CO2, you have a respiratory cause. If the pH matches the HCO3, you have a or put more simply, metabolic alkalosis is if the pH is alkalotic and the HCO3 is alkalotic. Respiratory alkalosis if the pH is alkalotic and the CO2 is alkalotic. Metabolic acidosis if the pH is acidotic and the HCO3 is acidotic. Respiratory acidosis if the pH is acidotic and the CO2 is acidotic. Is the cause compensated or uncompensated? Compensated is pH anywhere inside the normal range. Uncompensated is pH is anywhere outside the normal range, and the value of the CO2 or the HCO3 that does not match the pH will still be within the normal range. A partially compensated pH is pH anywhere outside the normal range, and the value that does not match the pH will be outside of its normal range, indicating the body is attempting to get the pH back to normal range. So here are some examples. We have a pH of 7.40, a CO2 of 37, and an HCO3 of 23. All the numbers are within normal range, so we have a normal ABG. For our next example, the pH is 7.23, the CO2 is 50, the HCO3 is 22. Is the ABG normal? No. The pH and the CO2 are out of normal range, so you must move on to the next question. Is the pH acidotic or alkalotic? Since the pH is less than 7.40, it is acidotic. Is it metabolic or respiratory? Since the pH is acidotic and the CO2 is also acidotic, then you have a respiratory acidosis. Is it compensated or uncompensated? Well, the pH is outside the normal range of 7.35 to 7.45, and the CO2 is still in the normal range. This is an example of an uncompensated respiratory acidosis. Now we have a pH of 7.36, a CO2 of 50, and an HCO3 of 29. Is the ABG normal? No, but both the CO2 and the HCO3 are out of the normal range. So we must move on to the next question. Is it acidotic or alkalotic? The pH is less than 7.40, so it is acidotic. Is the cause respiratory or metabolic? The pH is acidotic and the CO2 is acidotic, so we have respiratory acidosis. Is it compensated or uncompensated? Since the pH is within normal limits, it is compensated. In this example, we have a compensated respiratory acidosis. Here we have a pH of 7.50, CO2 of 42, and an HCO3 of 33. Is the ABG normal? No. Some of the values are outside the normal range. Is it alkalotic or acidotic? The pH is greater than 7.40, so it is alkalotic. Is the cause respiratory or metabolic? You know the pH is alkalotic, so you look for the matching value. The HCO3 is alkalotic, so it matches the pH. So what we have here is a metabolic problem. Is it compensated or uncompensated? Since the pH is outside the normal range of 7.35 to 7.45, it is uncompensated. Thus we have an uncompensated metabolic alkalosis. For the last example, we have a pH of 7.50, a CO2 of 18, an HCO3 of 24. Is the ABG normal? No. The pH and CO2 are both out of normal range. Is it acidotic or alkalotic? Since the pH is greater than 7.40, 4O, it is alkalotic. Is it respiratory or metabolic? Since the pH is alkalotic and the CO2 is alkalotic, you have a respiratory problem. Is it compensated or uncompensated? It is uncompensated because the pH is outside of normal range of 7.35 to 7.45. What we have here is an uncompensated respiratory alkalosis.